Oops, gotta add a note. All right, so here's section 7.1, exercise 26. And I just took a long time to do exercise 24. Um, but I wanted to show 26 is in 26 they mention this f of y and so forth. Well, um, so when they do that, f of y is y times 2 minus y, and g of y is minus y. Okay, when they do this, if you've looked in your text to get ready for this, they're not, in this case, just using some other letter. They're actually thinking, x is equal to y times 2 minus y, and x is equal to negative y. So they're kind of doing that, and they would say that if you graph this, you should still graph it this way. That's what they're in their lead-in stuff and so forth. Sure, okay, but I think it's just silly, okay, because this is hard to think about, and I have two perfectly good functions here. So fine, don't try to graph it this way. If you went to Desmos and tried to make that happen, it wouldn't be a pretty sight. Just do this. That's perfectly fine. And, so again, in Desmos, though, what I'm going to actually do to plot this thing is I'm going to plot, f of x equals x times 2 minus x, and g of x equals minus x. I'm going to switch the x and the y names. The mathematics doesn't care, right? It's a function that we can graph any way we choose, and so when I go to graph this thing, I'm just going to do it this way. And this is a parabola here, f. I got a 0 at 0 and a 0 at 2. And it opens down because that's a negative x times an x. And then y equal negative x, that's going down something like that. And we'll do that. Now, if you were to graph this on this other way, right, here's y, here's x, well, then now the y equal negative x, the interesting part there, or x equal negative y, notice that's, oh wait, sorry. Try that again. Normal axes, but we're going to swap out the, we're going to say x equals y times 2 minus y. So what happens is instead now you still get that parabola, and it still opens down toward negative x's. So, it does that, and you have this. And so, they're saying, okay, find that region. But if you go through this hassle of trying to draw it that way and so forth, it just makes it more difficult. Now, there's nothing wrong, with doing it this way, but if once I get something, as a function here and something as a function, I can always just forget whatever they've had me draw or whatever picture they've done, and I can just go draw it as I normally would. And that would be this thing, as opposed to trying to play their little game and doing this. Okay, so I'm just going to go with that first picture, so I'll redraw it. Okay, I want to find that area that has that function. I'm going to multiply through, so that's 2x minus x squared on top and minus x on the bottom. Now, I know that's at 0, 0. The question is, where do they match up down here? What's that x? Oh, shoot. Huh. That's what happens when you hit the little button on the pen. Okay, so what's this value here? Well, that's when minus x is equal to 2x minus x squared. So one case is definitely 0, 0. But another case, I'll just make this, I'll add x to both sides. You get 0 equals 3x minus x squared. Oh, that's at 3. And so we want an integral from 0 to 3. The top function is our 2x minus x squared. The bottom function is minus x dx. And so this is the integral from 0 to 3. There's a minus and a minus, so this is plus, so 3x minus x squared dx. So that is equal to 3x squared over 2 minus x cubed over 3 from 0 to 3, which is then the 0 is just going to go away. But so now I'll get actually 3 times 3 squared, which is 3 cubed, or 27, over 2 minus 27 over 3. And so now the 27 over 3 is just 9. And so I can write that as 27 over 2 minus 18 over 2, which is 9 over 2. So hopefully we get 9 over 2 when we check this. So I go to Desmos and I tell it that I want the integral. So where's my function stuff here? Do I have it there? Am I oh, there they are. Yeah. Huh, I don't know. Maybe my hand was in front of it. Okay, so we want to go from 0 up here to 3, and we had the 2x minus x squared, and then minus the negative x. So I'm just going to do my plus x. And then again, I'm going to see, can I forgot. Well, we'll just put the parentheses there since it seems to like those, dx. 4.5, that would be 9 halves. Heck, I can't even remember. Is that what we had, 9 halves? Yes, that is what we had, 9 halves. So there we go. And there is number 26. But so you see the idea, if I'm just told this, I don't have to get all anxious about the fact that what somebody might mean is this picture here. I can still draw my picture here, okay? Because it's still a function, a perfectly good function of an independent variable. Again, of an independent variable, I just draw them that way, unless I have some very important reason not to. I am just going to draw it this way because that's what I'm much better at. Okay, so there's 26.